Hi, you guys. We are going to be going ahead and we're going to be going over this genetics CSA, which is going to be your study guide. We're going to be taking this test next time that I see you. So I'm just going to get my pen going here. And we are going to go ahead and we're going to take a little bit of time to kind of go over this. Okay, so it says, below is my cat Sunny and his siblings. All four cats are orange and white. However, the youngest sibling, all the way to the right, has a condition called polydactyly. Tony has an extra toe on one of his paws, and you can see it beneath his mouse toy below. Given that that of the four siblings, only Tony has an extra toe, answer the questions below. Right, so just to kind of clarify, right, this cat right here, he has an extra toe that's happening right down there, right, and we need to go ahead and we are going to be going ahead and answering some of these questions. So the first thing first, they ask us if polydactyly is a dominant or recessive trait. So remember that a dominant is something that happens often, right, and a recessive trait is something that is rare. Right, so when we're going ahead and when we're thinking about this, we need to make sure that we know if the extra toe is common or if it's rare, right? So looking at the other cats, right, only he has it, so we can go ahead and we can assume that what he has is a rare condition, so it is a recessive trait. Okay, so going ahead and moving on, it says, using the Punnett square, show below the only way that Tony could have inherited his polydactyly. Okay, so we kind of have to work backwards a little bit here. So since it is rare and he has the recessive trait, remember, anytime you have a recessive trait, you're automatically homozygous recessive. Homozygous recessive. Right, so in this case, I'm just going to use A's, right, because I don't really want to use P's because P's can be confusing, right? So I'm going to be little a. So if Tony is little a, he's like right on there, right? That means that somewhere in here, Dad has to have an A and Mom has to have an A in order for that to happen. His other siblings, though, they don't have this, right? So since the other siblings do not have this, they have to have a dominant trait somewhere in there, right? And we know that his mom doesn't have it either, right? So it's just those cats. So if you were to go ahead and you would do this, right, you would see that that would be one way that Tony could have went ahead and inherited it, right? So that would be one of them on there. So dad's genotype could be capital A, and then mom's genotype is the same. So they're both heterozygous. Remember, heterozygous is one dominant and one recessive. It says, what were the genotypes of the potential siblings, right? So genotypes, remember, we're talking about letters. And those are our three possible genotypes. I'm going to remove that because that looks confusing. I don't want that to look like a letter. It says, what are the phenotypes? So you have to think of what the two phenotypes are. So one is the polydactyly, and then the other one is going to be normal, right? So one is normal, and one is poly. Right? What were the phenotypes? Yeah, so those are the normal and the polydactyly. Okay, so it says Tony has kittens with a female cat that does not have polydactyly, but one of her parents did have the polydactyly. Use the Punnett square below to determine how many of their kittens will have polydactyly. Okay, so Tony, we know that Tony has polydactyly, right? So Tony's genotype is little a, right? So we can go ahead and we can write that in there. It says that the female cat does not have it, right? So the female cat definitely has one capital A, right? So somewhere along the way, that female cat has a capital. Let me write it right here. Somewhere along the way, that female cat has a capital A, right? But we have to go ahead and we have to determine, okay, so what is the other letter, right? So it's capital A. And then it says right here that her parents did have polydactyly. So since her parents did have polydactyly, that means somewhere in there she probably has a lowercase a, right? So we can go ahead and we can make that assumption when we're talking about like one of the other parents. This is one of the ways to kind of assume that it's going to be heterozygous. So this is like a tricky way of, heterozygous. This is a tricky way of them going ahead and expressing that this is going to be heterozygous. So that would be that on there. So then you would go ahead and you would make that cross, right? And then possible genotypes for the kittens, capital A, and little a. They're not asking for percentages, but just to kind of as a refresher, right? Each box is worth 25%. So this is 25%, this one, that one, and that one. If we were to do percentages, about 50% would have the polydactyly, and then the other 50% would be normal, right? So those are some of those questions on there. Moving on, right? So this one is going to go ahead and this one is going to talk about these lifespan graphs, right? So the lifespan graphs are each of these things on here. Remember that as we talked about in class, lifespan graphs are going to be bar graphs, right? So these bar graphs are going to go ahead and they're going to express just how long they have lived, okay? So remember that we have talks, we have title, axis, label, key, and scale, right? The scale has to be consistent. I'm going to start by graphing this one. I'm going to graph this one on graph one. Okay, so on here I have, I'm going to go ahead and I'm going to erase this. And I'm going to go ahead and I'm going to put years here. And then on this side, I'm going to put fur color. Then I have to go ahead and I have to look at what my fur colors are. Black, black and white. So black, black and white, red, and white. I think I wrote it out of order, but it's all good. It's going to work out. Okay. So then I have to look at my thing on here and look at my years so I can pick a scaling that makes the most sense. So when I'm going ahead and when I'm picking this, I have to go ahead and I have to look at, okay, which one is going to make the most sense for me? So I look at this and then I have 9.2 years and that's pretty close to 10. So maybe I can go ahead and I can scale it up to 10. So remember that this has to be consistent, right? So I have to decide how I'm going to scale this. Let's go twos. 2, 4, 6, 8. I could probably do a better job of scaling this. 10, but that works. Okay. The next one is I'm gonna go ahead and I'm gonna make sure I have my Y. Whoa. That should be a Y and that should be an X. I'm gonna have average lifespan as my title. And then I'm going to go ahead and I'm going to go ahead and graph it. So my first one is 6.7 years. So for my black one is 6.7, so a little bit above 6. And I'm going to go ahead and I'm going to make that bar. Okay, and then my black and white is 9.2, so right under 10.